For the beam loaded as shown by virtual work method, determine the slope and deflection at B, and by Castigliano's second theorem, compute the slope and deflection at C. EI is constant. So for virtual work method, we compute first the reactions at A and B. So summation moment D0, AY times 10 plus 60 equals 30 times 7, or minus 30 times 7. So AY is equal to 15 kilonewtons. So if AY is equal to 15 kilonewtons, then summation forces Y, RD is also 15 kilonewtons. So there are three segments here. There are three segments of the beam where the loading changes. So we have this section here, this section, and to shorten the solution, so we have this section here in CD, and that's our X. So for the unit load, let's apply upward unit virtual load at B, because let's assume that the deflection and the slope are always positive. So if that is 1, reaction at A downward times 10 equals 1 times 7. Therefore, 1 times 7 over 10, 0.7. So this is 0.7 downward. Summation forces Y, so this should be 0.3 downward. Same sectioning as above. So take note that 1 times delta equals summation of integral 0 to L of Mamma Mia. Because EI is constant, let's just make it EI delta B equals the moment in this section is 15x. The moment in this section due to this reaction here is negative 0.7x. So remember, positive moment is clockwise if we consider left to right. So the moment at this section is 15 times x, while the moment in this section due to the virtual load is negative 0.7x from 0 to 3. Then on the next section here and forces at the left, big M is 15 times 3 plus x, then minus 30 times x. That's the big M. 15 times moment arm 3 plus x minus 30 times x. Then due to virtual forces, 1 times x minus 0.7 times 3 plus x. So again, 1 times x positive, then minus 0.7 times 3 plus x. That's it. Then in this section here, remember positive moment is counterclockwise this time. 15 times x, then due to small m, negative 0.3 times x. So plus integral 0 to 4 of 15x times negative 0.3 times x dx. So the evaluation of the integral is not shown here, but you may have it in your scratch paper. So because high-tech calculators are not allowed, we have to evaluate this one by one. And the value is negative 94.5. For the next integral, we may simplify it before we integrate, but the value is equal to negative 121.5. And for the third, this is simply negative 4.5x squared dx. So the integral from 0 to 4 is negative 96. So combining, delta B can now be computed, and it is equal to negative 312 over EI. Next, for slope at B, so we just draw due to virtual force, counterclockwise positive. That's the assumption. So if that is 1, reaction here, summation moment D, reaction here times 10 equals 1. So therefore, the reaction here is 1 over 10 or 0.1 upward. Summation forces Y, so this is 0.1 downward. Same sectioning. So the formula is 1 times theta is equal to summation integral 0 to L of m big M sub theta dx over EI, where m sub theta is the moment at same section due to these virtual forces. So cross multiply EI theta B is integral from 0 to 3, copy the big M here, which is 15x. Then the moment at this section this time is positive, also 0.1 times x. Then in this section here, we copy the big M, which is integral 0 to 3 of 15 times 3 plus x minus 30x. The small m this time is 0.1 times 3 plus x minus 1. Again, moment in this section is positive 0.1 times 3 plus x, then minus 1. Then lastly, in this section, we have integral of 0 to 4 of 15x. Then the moment in this section is negative 0.1 of x, 0 to 4. So again, the first is integral of 1.5 x squared, 0 to 3. So by manually evaluating the integral in your scratch 13.5, here you may simplify before you evaluate the integral. But the value of this is equal to negative 40.5. Finally here, negative 1.5 x squared 0 to 4 is negative 32. So combining these values, 13.5 minus 40.5 minus 32, so theta b can now be solved. It is equal to negative 59 over EI. Then by Castigliano's second theorem for the deflection at C, we apply a force, upward force of P as shown in the figure. So remember, due to the actual loads, the reaction here was 15 kilonewtons upward. Then let's just concentrate on P. So reaction here, which is downward, equals reaction times 10 equals P times 4. So P times 4 over 10 is 0.4. So therefore, this is 15 minus 0.4 P. Again, this 15 here is due to the actual loads. Then if we concentrate on the 4P, because this is upward, the reaction is downward or negative. So reaction here times 10, summation moment at D equals P times 4. So P times 4 over 10 is 0.4P. So 15 minus 0.4P. Likewise here, this is 15 minus 0.6P. Or reaction here due to P alone, concentrate on P, times 10, then equals P times 6. P times 6 over 10 is 0.6P. So 15 minus 0.6P. So the formula 1 or deflection is equal to integral for summation of integral from 0 to L of big M, partial of M with respect to P, then dx over EI. So EI delta C therefore is just concentrate on big M's from 0 to 3. This is big M, 15 minus 0.4P times X. So the partial derivative of this expression with respect to P is negative 0.4 of X. The negative 0.4 of X is the partial derivative of M with respect to P, which is this. Then in this section, the moment is integral from 0 to 3 of quantity 15 minus 0.4P times 3 plus x minus 30x. The partial derivative of this moment equation with respect to P is just like setting P equal to 0, or cancelling out P. So which is negative 0.4 of 3 plus x. So that's the partial derivative. And finally, in this section, we'll just place it here. And anyway, the order does not matter. It is integral of quantity 15 minus 0.6p of x. Then the partial derivative is negative 0.6 of x. Because the partial derivative is, the variable is p. All the other present items will be considered constant. So negative 0.6p negative 0.6p times x, the partial derivative is negative 0.6x dx. So prior to integration, we have to set the value of p, which is 0, because this is just invented. So if this is 0, this is now integral 0 to 3 of 15x, then negative 0.4 of x only. And that integral from 0 to 3 is negative 54. For the next integral, which is this, set p0 because it doesn't exist. We just invent it. So it is integral of 15 times 3 plus x minus 30x, then times negative 0.4 of 3 plus x. So simplifying, you may simplify before you integrate. The value is equal to negative 108. Then finally, for this expression, this is 15x only because p is set to 0. So 15x times negative 0.6x, from 0 to 4, the integral is negative 192. So combining, delta c can now be computed, negative 354 over EI. Then for the slope at C, we apply a couple at C. So just concentrate on the couple. The reaction here, summation moment, the reaction here due to the couple C times 10 equals the couple. Reaction times 10 equals the couple. Therefore, the reaction here is couple over 10 or 0.1 C. Since due to the actual loads, it was 15 upward, then due to the couple, 0.1 of couple. So this is now 15 plus 0.1 of couple. Likewise, summation versus y, this should be 15 minus 0.1 of C, or the couple. So same sectioning. So EI, theta C, or theta is summation integral of 0 from 0 to L of m, partial of m with respect to the couple dx over EI. So EI theta C is equal to integral of quantity 15 plus 0.1 C times x. The partial derivative with respect to couple is 0.1 of x. So it's just like ignoring C after you partial differentiate. So C is the variable here. So 0.1x dx plus, in this section, the moment is quantity 15 plus 0.1 C of 3 plus x minus 30x. And the partial derivative of this with respect to the couple is 0.1 times 3 plus x. Again, 0.1 times 3 plus x, which is that. Then in this section here, the integral, the moment is quantity 15 minus 0.1 C times x. So the partial derivative is negative 0.1 of x. So prior to integration, set C0. Simplifying the first, so we have integral 0 to 3 of 15x times 0.1x dx, and the value of the integral is 13.5. Here, because c is 0, this is integral of quantity 15 times 3 plus x minus 30x, and times 0.1 of 3 plus x dx. So simplifying first inside, then simplify this, then the value of the integral is 27. Lastly, for the last, this is set to 0, so it's 15 times x times negative 0.1x from 0 to 4. The value of the integral is negative 32. So combining, theta c is equal to 8.5 over EI. So that's it for this example.